So section 4.4, I broke into a couple parts. Shh, guys. Hello. Section 4.4, I broke into a couple parts. So part 1 is on a review of inverses, like how to find an inverse, and exponential and log functions. So you've done this in Algebra 2, but as we've seen, sometimes you guys forget things. So we're going to do a little review, a little refresher. All right, so it says a function f is called a one-to-one function if it never takes on the same value twice. Okay, so one-to-one is going to be kind of like, you know, the function rule, like if it passes the vertical line test, it's kind of like that, but it's the horizontal line test. So basically, you can't have like a parabola that wouldn't be one-to-one because it takes on the same y value twice. So you can't have that. So if something is one-to-one, then you can take, or you can find the inverse. There's a unique inverse that goes with it. Okay. So it says r f of x equals x squared and g of x equals x cubed one-to-one. So I just told you f of x equals x squared, right? I said no, it's not one-to-one because, yeah, it's a parabola. Basically, like the point 2 comma 4 and negative 2 comma 4, they have the same y value. So if you ever have the same y value, there's not a unique inverse. Because remember, an inverse is where you switch your x and y values. So basically you're saying, is the inverse going to pass the vertical line test? Is it a function? No. All right, and then x cubed. Does that pass the vertical or the horizontal line test? Yeah. So it's good. Okay, so then we talk about how to find an inverse. So we did that in Algebra 1 as well, or Algebra 2 as well. So what we do is we replace our f of x with y. And then we solve for the new, well, we switch the x and y, I guess. And we solve for the new y. You guys remember this process? So we get x minus 2 equals y cubed. We take the cube root. I don't know why that looks like I crossed it out. So we get that. And we write it as f inverse of x equals the cube root of x minus 2.
You kind of saw
Yeah, you need to say f inverse or g inverse or whatever it is. All right, so find the inverse of this function. So for this one, we have y is equal to, cut off a little bit, 4x minus 1 over 2x plus 3. So we're going to switch our x and y's. Now that you guys have kind of solved for dy over dx with the implicit differentiation, you probably know what you need to do. Sorry. Just. All right, so as I solve for y, what do I need to do? You guys remember how to do this? These are like the hardest ones you had in Algebra 2. Yeah, first we're going to multiply the denominator over, so I'm going to have x times 2y plus 3 equals 4y minus 1. So I get 2xy plus 3x equals 4y minus 1. And then get all the y's on one side, just like you did with the dy over dx stuff. So I'm going to have 2xy minus 4y equals negative 1 minus 3x. It allows me to pull out the y and solve. So you get y equals negative 1 minus 3x over 2x minus 4. So y is f inverse, or g inverse in this case, right? So don't write f inverse, because then you'd really miss it. Okay, so it's like that. Now what you guys were asking me before we started was, you know, you had a different answer on your implicit differentiation than someone else did, because the top and the bottom were just all the signs were opposite. You could multiply by a negative 1 on the top and bottom. Bad notation. All right, and you could also have g inverse of x equals 1 plus 3x over 4 minus 2x. That would also be equivalent. In your AP test on the multiple choice section, they're probably going to do the one that has the least number of negatives. So they would probably do the second version. Okay. Okay, so how do you take the derivative of an inverse? So it's a little bit weird. The derivative of an inverse ends up being 1 over f prime of f inverse of a. So I tried to explain that, and you guys have a picture that I don't have on this notes file. You remember how inverses are a reflection over the line y equals x? So if you have something that looks like this for your original function, I guess that's the inverse function, I guess this is f of x, they say. So if this is f of x, then f inverse of x is going to be a reflection over the line y equals x. Okay, think about how we found the slope, the derivative. Okay, when I first taught you a derivative, I made you do that like f of x plus h minus f of x all over h. Yes, a lot of you aren't paying attention at all. It's driving me crazy. You're like talking to your neighbor, your eyes are closed. Don't do that. This is a very hard theorem. It's a good one to know. All right, so if you have f of x and you have its inverse, f inverse of x, if I'm finding a slope at a certain point, we did the limit as h went to 0 of f of x plus h minus f of x, you know, like that whole formula. Basically what that is the difference between two y values and the difference between two x values that are really close, like the change in y over change in x. Okay, now think about the inverse. We said that for an inverse, you switch your x and y values, right? So the inverse function is going to have the difference in the original x values over the difference of the original y values. You guys understand what I'm saying?
So is it not slope?
It is the slope. It's just the slope of this new thing, the inverse. Okay, it's really the new y values over the new x values. Okay, now think about what that creates. So let's say I had 2, 4, and I had 3, 10 for my original function. Okay, if I find the slope, I do 10 minus 4 over 3 minus 2. But if I do the inverse, I'm doing 4, 2, and I'm doing 10, 3. How is its slope going to be different? It's going to be flipped. What's the math word for that? It's the reciprocal. Okay, so the inverse is going to have the reciprocal for the slope. Do you guys understand what I'm saying? It's not going to be the opposite reciprocal. It's not going to be perpendicular. It's just going to be the reciprocal. And that's what I kind of tried to draw out for you guys in your notes page. So you guys have something, and it talks about at a particular point, like at this point, you have a certain slope, but then at its corresponding point, you have like a steeper slope. They end up being reciprocals of one another. Like one could be positive 2, the other one could be 1/2. Do you guys understand what I mean by that? Okay, so if you want to find f inverse prime of a, what you have to do is you do 1 over, so you do the reciprocal, and then you do f prime of f inverse of a. It's kind of weird. I'll explain what that means. So this first one is saying f of x is equal to 2x cubed plus 3x squared plus 7x plus 4. Find f inverse prime of a for a equals 4. Okay, so what this is going to be is f inverse prime of 4 ends up being 1 over, and you switch the two things. You switch the inverse and the prime. So you get f prime of f inverse of a. It's hard to do a parenthesis in f's. There we go. So my a is 4, I guess. I need to put that in there. Okay. The hardest part of this process is finding what f inverse of 4 is. Can anybody do it in their head? So you're saying, in the original function, you want to plug in something and get 4 out in your original. So I'll do f. What do you plug in to get 4 out? 0. Good job, Abby. Do you guys see it?
What if you did the inverse process, like switching the axis and size and plugging in for that?
You could, but do you want to find the inverse of that? Try it. Try to find the inverse of that. It's not fun. How do you, I mean, you can try it. You're not going to be able to do it. You're not going to be able to find the inverse. Okay, so since this is a one-to-one, like we're talking about one-to-one functions, that's the only value that when I plug in something, I'm getting 4 out. Does this make sense? Okay, so if I have f inverse, when I plug in 4, I'm getting 0 out. They're opposite each other. So that means we really have 1 over f prime of f inverse of 4. That's saying if I plug 4 in for x into the inverse function, I get 0. Okay, so from this picture, it's basically saying, like, I don't know, this point right here that I'm drawing in really dark, it's going to be like opposite x and y values of this point right here. Okay, So we're saying, what x value did I plug in to get a y value of 4? So that when I plug in 4 for my x, I get that y value. That's what we're doing. Did you guys see? Okay, so then I have 1 over f prime of 0. So then I need to find f prime of 0. So first I find f prime. Running out of room. F prime of x is going to be, looking at my f function right here, it's going to be 2 times 3, so 6x squared plus 6x plus 7. So f prime of 0 is 7. So your answer is 1/7. Because it's the rule, the 1 divided by is the reciprocal thing. All right, a little bit confusing. Okay, so why do we have to do that? So
Wait, so it's 1/7 or 7?
it's 1/7. So the slope of the original at 4, is it 4? No, at 0 should be 7. They should be reciprocals of each other. No, the slope of the, what am I talking about? I don't know. I gotta think through. Yeah.
First blue thing.
The first blue thing.
Yeah, f prime of x equation.
Because I looked at my f of x equation here. Does that make sense? All right, so let's go through this whole process again. So same thing. They're tricky. Okay, so first you memorize the formula. You know that if I have f inverse prime of a number, so in this case it's 2, I'm going to have to do 1 over f prime of f inverse of 2. You guys agree? Okay, I need to find f inverse of 2. So what I'm saying is for the inverse function, I want to plug in 2 and get some number. So for the original function, that means I want to plug in a number to get 2. This one's a little bit harder to do in your head. So Abby was really good on that last one, and she said, oh, I want to get 4 out? Well, I'm going to plug in 0, right? They're usually pretty obvious. Close. It is 3 over 2. Good. Oh, yeah, you did say 1.5. Yeah. I thought you were saying 1/2. I heard someone say 1/2. All right. Okay. So it ends up being 3 over 2. If you needed to do that off the side, you could. You could say 1 over x minus 1 equals 2. You could multiply it over and so on. You could get it, right? So 2x minus 2 equals 1. So 3 equals 2x. So x is 3 over 2. Like, you can do that. So you get 3 over 2. So that means when I continue this right here, see, it's kind of like you have to do like side note, side note, side note. You get 1 over f prime of 3 over 2. Well, can you find f prime of 3 over 2? Yeah, you just find f prime. You could do quotient rule or chain rule. How could you do chain rule? X minus 1 to the negative 1. So when you do the derivative, you get negative 1 times x minus 1 to the negative 2 times chain 1 in this case. Okay, so you would have, when you plug in 3 over 2, what do we get? It's a lot of work, isn't it? So we have negative 1 times x minus 1 squared, basically. So I have negative 1 over 3 over 2 minus 1 squared. So negative 1 over 1/2 squared 1/4, negative 4. So you get 1 over negative 4, which is negative 1/4. A lot of work.
Yeah, so if we do the chain, we get negative 1 x corresponding to negative second plus 1. Can you just plug in 3 over 2 right there? Or...
Yeah. Then you have to raise it to the negative 2.
Why is it negative?
Because it was 1 over. So 1 over 1/4 is negative 4. Negative 1 over negative 1. Negative 1 over positive 1/4 is negative 1. And then you plug it back in here. All right, complicated, isn't it? The good news is I've only seen this one time on a multiple choice question. The bad news is every year the AP test gets harder. So,
Wait, really?
yeah. You know, because you guys get better and better. Teachers get better and better, and you guys get better and better, and they set it to a curve. Like a little 3s, 2s, 4s, 5s, and 1s. And sadly, I told you usually 5s or 1s are the scores that I get. You either get it or you don't get it. So I'm just saying in my class, that's what you get. So I don't know. Maybe the really good students at other schools just get 4s. I don't know. My really good students get 5s. So be a really good student. All right. My really bad students get a 1, though. They don't get the 2s or 3s. So in your previous math classes, you've learned that exponential functions have an inverse. So we say that a to the y equals x. So you guys remember a to the y equals x. If log base a of x equals y. So in Algebra 2, I taught you the little, like, use your finger and go from one to the other, like, doo, 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 like that. So a to the y equals x. A to the y equals x. It's like you're conducting an orchestra. Do, do. All right. You've also learned these other properties, that if you have log of a times b, it equals log of a plus log of b. All right, the power property. We'll do quotient properly. This is log of a minus log of b. Do you guys remember these rules? Yeah. Power property, what do we do with that little m? Goes to the front, yep. So it's going to be m times log of a. Inverse property, so if I have log base a of a to the m, it becomes m because the log base a and a cancel. All right, change of base formula. If I have log base b of a and I want to use my calculator, but my calculator doesn't do log base 7 or log base 11, I do log of a over log of b. Or you could do natural log of a over natural log of b. In our case, that's what you'll probably want to do, natural log. You'll see. Natural log is an easier derivative. All right, and a to the log base a of m is also m. They cancel each other out. So basically, if I have 3 to the log base 3 of 11, it becomes 11. All right, limits of logarithms. Back to limits. So the limit as x goes to infinity of log base a of x, it goes really, really slow, but it's infinity. So if you guys got your calculators out and you did like log base 10 of 5 million, right, it's really, really small. But if I did more zeros, it gets a little bit bigger, right? I don't know. It doesn't go very fast, but it goes to infinity. All right, and then as I go to 0 from the right, what do I go towards? Negative infinity.
That was really good.
Yeah, that's what I was.
It was what?
It's really good.
Oh, I've perfected my infinity drawings over the years. I still see people turn their page and write 8s. It's cool. I don't judge. All right, here we go. All right, so we're going to try to use not use our calculator on a lot of these, but when you need to use your calculator, you'll know. It's usually a change of base one. Okay, so this first one, so I have log base 3 of 3. What is that? 1. What's this next one? 8, right? 3 to the log base 3 cancels. 2, because it's 9 to the second equals 81, right? So this is 2. No. So we have 9. Let's write an x. So if I have 9 to the x equals square root of 3. Okay, we did something in Algebra 2 where we wrote things with powers, like the base and different powers. So this is 3 to the 1/2. 9, how can you write that as 3 to something? 3 squared, right? So 3 squared. 3 squared to the x. So it's 3 to the 2x equals 3 to the 1/2. So 2x equals 1/2. So x is 1/4. So a lot of you guys knew that right away. Like I heard some people saying 1/4. Because you're going to have to take the square root of 9 once to get 3, and then the square root again to get square root of 3. So 2 square roots is really a fourth root. Okay, how about here? Do not say it's log base 4 of 189. Don't say that either. What is it? What do I have to do? Division. 192 divided by 3. Do you guys know what that is? Log base 4 of, if you don't know, then you can, oh, I don't know why it does that. It keeps doing that today. If I do 192 divided by 3, I could do that. I would not die without using my calculator. True story. You get 64. So you should have 4 to the Then you're like, oh, 4 to what power gives me 64? Then you start just saying 4 times 4 is 16 times another 4 gives you 64. So it should be 4 to the 3. Gotta know those ones. Gotta know 4 to the 3. All right, here we go. Log base 2 of 6 minus log base 2 of 15. That's going to be log base 2 of 6 over 15. But then we're going to have times 20. Is the plus. So we can reduce out just like normal. 15 and 20 divide by 5. I get 4 and 3. And then 6 and 3 reduce, reduce. I get 2. So I really have log base 2 of 8, which is 3. Yeah. All right, how about this one? 1/2 of log of 16. How would the AP test write that? Log of what? Nope, 16 to the 1/2, which is log of 4. The 1/2 power is the square root. Right, this is what I was saying can be painful on the AP test because all of their answers are in like the most simplified logarithmic form. So you might have 1/2 of log of 16 and you don't have your calculator and you're like, oh, what is this? Why do they have log of 4? How did they get that? Right, you got to know these rules. All right, this one, log base 11 of 121. Easy. 2. No, 11 squared. 11 to the 2 is what gives you 121, not 11 to the 11. All right, how about this one? This is harder. 2 to what power gives you 30? I don't know. What's it going to be close to? Pretty close to 5, right? So let's do it. So let's do log of 30 over log of 2 on our calculator, and we'll round to 3 decimals like the AP test. What do you get? 4.907. Thank you. You can always round or truncate. So if it was 4.9079, you can round to 908, or you can just chop it off. Yep. You could find it as a decimal. Yeah. All right, how about this next one? So J, log base 8 and 8 cancel. 2x minus 1. This one, 5 to what power gives you 125? 3. And this one, 7. Do you guys like those?
Yeah.
Good. Next page. Expand the logarithms. This will be very, very useful in the future. You don't know why it's useful yet, but it will be very, very useful. It's going to make derivatives much, much easier. All right, so if I have this, if I want to expand it, I'm going to have log base 8 of 5 plus log base 8 of y squared. And then I can pull powers to the front. So I'm going to do log base 8 of 5 plus 2 times log base 8 of y. Everybody see how I got that? So powers can go to the front. Product means that I'm really adding my logarithms. So something like this next one. So imagine taking the derivative of this inside part. Would you want to do that ever? No. Does that send you into a fit of panic looking at how to take the derivative of the inside part? That's why I'm saying you want to learn this. You want to know how to expand. It's going to make it easier. So you're going to have log of x squared plus log of cube root of x minus 1 minus log of 2x minus 1. Oops. All right, so you're going to have 2 times log of x plus 1/3 log of x minus 1. Do you guys see where I got the 1/3? Minus log of 2x minus 1. You cannot break up the log of 2x minus 1 part. Because if you have like the difference, you don't like get a product or something or quotient. Right? You have to have like log of something plus log of something else in order to add them. You can't go the opposite direction. All right, so same idea here. So now we're going to combine. So we're going to take something that's separated and push it together. So we're going to have natural log of 6 plus natural log of x cubed plus natural log of x squared minus 2 squared. So when you combine it to 1, I'm going to have natural log of 6x cubed times x squared minus 2 squared. And I'm going to put brackets so I know it's natural log of all of it. All right, same idea on the next one. So it's going to be log base 3 of y plus log base 3 of, it's going to be 81 to the 1/2. What's 81 to the 1/2? 9. It's the square root of 81. Plus log base 3 of x minus 2 squared. So we get log base 3 of 9y times x minus 2 squared. Oh gosh darn, I don't know why I keep doing that. It's driving me crazy. X minus 2 squared. Oops, bracket. So we get that. Okay, one last thing. We'll do that in a sec. Well, we'll do it next time. Okay, solving log equations and so on. Yeah, skip it. Do you guys remember how to solve log equations? Like this one, you could get them to be the same base. 3 squared to the 8 minus x equals 3 cubed to the x minus 3. So this would be 3 to the 16 minus 2x and 3 to the 3x minus 9. So you get 16 minus 2x equals 3x minus 9. So we get 5x, and we add the 9 over, equals 25, so x is 5. That one's easy enough. But if we don't have things that we can get to be the same base, we have to do a different method. Okay, so we can't get 4 and 5 to have the same base. So you could do one of two things. You could switch forms. So if you switch forms, it's log base 4 of 5 equals x minus 1. Do you guys see that? 4 to the x minus 1 equals 5. Yep, you do your change of base. So you'd have log of 5 over log of 4 equals x minus 1. You'd find this on your calculator. So who can do that for me? Lydia, you on that?
Wait, so log of 1 is 1, 0.
Okay, so 1.161. Yeah, Nia?
Why would, when you take the 4 and do the little squishy thing and make it like the same thing, how do you make it so you don't get like the same thing?
Like, I don't know what you're saying at all.
Okay, so you know when you like circle circle the base?
Like, how did I get to this step?
Okay.
Like, I did something called the change of base formula. So if I had log base 7 of 21, it'd be log of 21 over log of 7. So it's the change of base formula. Remember that?
Oh, okay.
All right, so this would end up being 2.161 equals x. All right, what about something like D? 6 to the negative 1 equals 2x minus 1. Do you guys see how you switch forms? And you continue to solve. All right, what's the other way you could do B?
You can do log of 2x minus 1. Wait,
B, you could just do log of both sides. Right, as long as you're doing the same thing on both sides of the equation, it's fine. Pull the power to the front. Equals log of 5. And then divide by log of 4. Do you guys see how it's exactly the same as the change of, like, switching originally and doing the change of base? All right, so I'm going to give you some problems to practice, so to review.